Welcome to our live stream here from the very sunny Munich, and I'm very honored and exciting to be moderating and guiding you through this afternoon session and to this special event with the title From the Data to Deployment with hosting DeepL and NVIDIA. We will talk about what it takes for large-scale AI training and inference, the business impact of localized language models, and we will gain some insights into real AI use cases for the AI-driven future communication. I promise you, by the end of the session, you will have a deeper understanding that scaling massive models will, in the future, you will have fewer infrastructural headaches and greater efficiency in global language solutions. My name is Sarah. I'm an AI expert and tech futurist, and I have more than 10 years experiences in the AI space, and I'm very honored to be here today with Stefan Meskin, Chief Scientist at DeepL, and Adam Janakovsky, Senior Solution Architect Team Lead at NVIDIA. We have a lot to talk about, and we have only limited of time for this massive topic. But first, I want to make sure that you are at home, the audience, that you are all set up for the session. So obviously, we also want to know your questions because we're going to learn a lot. And whenever we learn more, we also have more questions. So you will be able to drop these questions in the chat. So the chat will be monitored. And by the end of the session, once I'm done with asking the gentleman all my questions, I'll have the time and I will get your questions onto stage, and we will have the time to directly answer them live here in the session still. But don't worry. So if we don't get to your question, we will keep having the conversation with you afterwards on the social media platforms. So no worries. Please feel free and drop all your questions that will arise. So I already named your name, obviously, and the title and the company, but obviously I'd like to give you the stage and the opportunity to introduce yourself, your responsibilities, and also your mission. So let's start with you, Adam.
Myself? Oh, thank you. My name is Adam, and I'm at NVIDIA for almost 10 years now. I always work with neural networks, so personally I focus on a problem of scalability of neural networks. It was quite a niche problem at the time when I picked it up, but it turned out to be quite pivotal for the stuff that we are doing right now. I also lead a relatively small team of engineers, scientists, I'm not sure what name to use, that work with our key customers to make sure that, in a sense, they are technologically successful, to help them get unblocked whenever they get blocked by neural networks, our technology, our software, our hardware, and to try to make sure that they build the technologies that they need and help us also improve our tools, our systems.
Great, thank you. Welcome. Thanks for being here.
I'm Stefan Meskin, Chief Scientist of DeepL. I have been in AI for the better part of a decade now, 5 years with the company. During that time, we have seen a lot of growth, of course, so my role has also changed dramatically. I started as a research scientist training translation models for Japanese and Chinese specifically. That was my onboarding task. Since then, I've dived into like different parts of the business. Policy assurance, always super important. And I've had the pleasure to build by now 3 AI factories, all powered by NVIDIA as a course of this. And our ambition is to build even more capable models and now lead a team, well, many teams of, again, like engineers and research scientists to facilitate all the AI model development that happens at DeepL.
Thank you to both of you. And what I like to do often at the beginning of interviews, because we have a lot of technical topics today, but in the end, we are all humans working in the technical field. So I'd like to raise a personal question to you. Do you remember the very first moment that you personally realized that the technology, that AI is going to drastically change how we live, how we work, how we communicate, and that we're heading into a very exciting future? Do you have like a core moment that you remember?
Yeah, for me, it's 2 moments. The very first was when I was like 7 years old in the middle of the 90s. I still distinctly remember how my uncle gave me my first computer ever. Right? It was built up in the basement, monochrome display, nothing to speak of. Even back then, it was ancient technology, and he essentially said, "Okay, like here's a computer, here's a manual in English, nonetheless. Figure it out." And the reason I got into technology is not so much by like having a grand plan for my life, but because this was the one area where I could shape my own destiny without having to ask anyone for permission. Right? Like there's this box, and whatever anyone can do on this box, you are in principle also capable of doing. This is incredibly powerful, especially for young children. And then the second moment was in 2018. Like again, very distinctive moment. I was a researcher at the university back then in mathematics, and I recognized that AI, which had been on my mind for a while, is now really taking off. And there was this feeling every time I sat down at the front of my desk, recognizing that there's all of this exciting stuff happening, and yet here I'm building knowledge for a very like elite and ivory tower kind of group. Back then I decided to leave academia to pursue that opportunity, which is a call I'm very happy about in hindsight, even though it was very difficult to do back then.
I can imagine, and they're very human-driven reasons. So you're combining the human aspect of leveraging that every human can leverage the technology.
Yeah.
That's I like that.
Absolutely.
Thank you.
Like me sitting in front of the desk and thinking about, okay, how many people are going to see what I'm doing here, and if I'm really hitting this out of the park, it's going to be like 100 people. I was in a field that was very small. In the meantime, like all of this exciting stuff is happening that is really shaping or reshaping how people live their daily work. And that spark of insight really carried through. Back then, no one cared or knew what I was doing. Now everyone does. And that is not driven by the technology itself, but how this technology impacts how people work.
Great. And now you're here educating a lot of people also here today in the stream. Do you also have one of these moments in the past?
Well, I'm not sure whether it works like that, in a sense that you're born or shaped to be curious. Yes, like and you have to have this attitude of being excited about technology changing, and that needs to bring you pleasure. Otherwise, it's just overwhelming. Things change too fast. So I was always excited about building things, however small or complicated they are. When it comes to pivotal moments, sometimes it's easy for us to retrospectively look at our history and place significance on certain events, but they're typically not obvious at the time. So, like I personally, I knew about the changes in computer vision that were taking place at the time where AlexNet was published, but it did not become obvious to me at the time that neural networks unavoidably will work. For me, at the time, I think 2 years later, I was working at Jaguar Land Rover in the research department and was co-responsible for some of the work associated with automatic speech recognition. Yes. And at that time, Andrew Ng was at Baidu, if I remember correctly, with Adam Coates, and Brian Catanzaro, who right now works and leads one of our applied research groups at NVIDIA. And they were designing recurrent neural networks for that problem, for automatic speech recognition. And as part of that project at Jaguar Land Rover, I've done quite a thorough literature review of what they've been doing at the time. And for me, that's an important moment, because at that point, I've realized that like this will work. It wasn't just a matter of, this will work for this particular problem, but it became very clear to me that neural networks will holistically work. And that's a very important moment to me. That's when I decided that I need to double and triple down on this space of technologies. And personally, for me, that's an important moment.
Thank you for sharing. I think that's a great aspect to take away, that we the curiosity that we had in the past, and that will just exceed even by right now, day by day, with all the new technology arising. And that's the perfect bridge, because we talk about technology today. And maybe we start at the very high level question towards you, Stefan, that you briefly explain our audience what does DeepL do, and especially what kind of challenges do you enable businesses to solve their problems? Yeah.
I think in order to understand what DeepL does, it's important to recognize the environment DeepL was brought up in. So the company was founded 2017 in Cologne, Germany. And similar to what Adam just described, there was this recognition that all the puzzle pieces are here to reshape how we interact with technology on a global scale. And the area where this worked the best back then, and to a large extent continues to do so today, is natural language processing. So bridging the gap between humans and computers at the end of the day, ensuring that we can communicate on equal footing. Driven by like a highly curious but small team of research scientists back then, the decision was made that the team wanted to leverage the capabilities it already had and essentially apply neural networks to the same problem of translating languages from one natural language to another. This really reshaped how this entire domain thinks about this problem, because like the idea of translation wasn't new, right? Especially in the Cold War, this was like on everyone's mind. Wouldn't it be great if we had this technology? But it never really like crossed this threshold of good enough for seamless communication. And all of a sudden, this changed in 2017. Parts driven by the transformer architecture. Yeah. So all the puzzle pieces just came together, and since then, DeepL continues to invest in translation, is now also in speech translation, of course, but the company is so much more than that, because at the end of the day, what we do is we take the best available technology in AI, continue to push it further in order to solve specific problems for business customers. This has informed every single product launch that we had at DeepL, like including Translator, of course, the writing assistant that we've launched. DeepL Voice now is at a similar moment in time compared to where Translator was 2017, in that we have all the puzzle pieces to make speech-to-speech communication across language barriers seamless. And now, most recently, of course, with the launch of the DeepL Agent, we apply once again very similar technology to a new problem, because we realize that there's so much more that we can do for our customers.
Yeah. And it was a bold decision, admittedly. Like sometimes it's easy from the outside to look at a history and try to retrospectively identify that chain of events that led to where we are right now. But it was totally not obvious at the time. In 2017, it was not obvious that translation is a problem that one can actually solve sufficiently well with neural networks.
Yeah, absolutely. Like always in research, it's not a given that you can achieve the level of quality, the level of sophistication that you need in order to address the problem. That's kind of the distinguishing line between research and pure engineering. Since then, like we have made many additional bold bets, venturing into writing assistants, into DeepL Voice, building these AI factories to reshape how the model architecture works underlying it. And at every point in time, there is this not only moment, but this extended period of uncertainty. Like, can we actually do this? And to some extent, it requires just self-belief in your capabilities and also the overarching mission.
I read, it's not a fun fact, it's a very interesting fact, what you're just describing, that there was a turning point in history, because I read that back in the days, it was just a theoretical idea, what would it take to translate the whole internet? And that in theory, it would take 197 days, when I read it in your paper. And we will get to the point technically later in the questions, how we now are down, that it's actually becoming possible, and that we are down to 18 days, which is amazing to think about. And you will get a question about that, how you actually got there. But like this is for me as an end user very easy to understand, like the whole internet being translated in just a few days. Yeah. And what we also promised our audience is that we talk about sovereign AI, because we are here in Europe. And what was interesting for me is really the main question: why build and operate models? Like, why not build a thin wrapper like a lot of other companies do? Feel free, Adam, start.
So why do automotive manufacturers build engines?
Mm-hmm. You ask me?
Yeah, why do they do that? why don't they buy it from, I don't know, whomever, Ford?
Yeah, because we are not the expert.
No, because they want to have control, over some of their properties. Yes, they want to have some negotiating power when it comes to pricing, even if they choose to buy them. They want to have some roadmap of technologies that they want to develop. They want to have differentiation when it comes to capability. Yes, they want to have control about other aspects of the vehicle design that would be impossible with an off-the-shelf or even heavily customized model. They want to have control over the supply chain. Yes, ability. So for exactly the same reasons, one would choose, I guess, to develop their own models. Like, if something is important to you, there is a point where it's strategically important to have control over it.
Mm-hmm. I like the metaphor.
Yeah. For DeepL, this is a fairly new question, honestly, because in 2017, this was a non-event, right? If you wanted to do translation at a level that has never been seen before, you have to build the technology from the ground up. And we were fortunate enough to be in a position to be able to do this back then. Nowadays, there's so much more development in the general AI model development space that I think it's important to ask that question, because the answer is not obvious, right?
Of course.
There are very convenient shortcuts you can take in order to build great AI products on top of existing models. I worry that as a result of this, we might not only lose control over the core technology, but also fundamentally the necessary ingredients to accelerate this.
Sure.
Right now, like at this point in time, 2025, we have all the necessary puzzle pieces to not only build AI models, but to build the best AI models that there are on a global scale. And this is ultimately the benchmark we will be measured against. If we don't capitalize on this, we will lose talent, because first of all, the talent that we already have will look elsewhere for opportunities. We will also not develop this talent, right? Like, okay, we are in a point in time where we kind of understand at DeepL how to do these model developments. The frontier of how this is going to look like is it's reshaping at a drastic scale.
Yeah.
Every week, new discoveries are made.
Correct.
So if we don't keep pushing that boundary, the knowledge that we have right now will lose value tremendously quickly over time.
Sure.
And then finally, there's the infrastructure part. So there are, like, if you really squint at this, only two differences between software engineering and AI development. One is the research part, right? It's not given that you can solve the problem. There are like inherent risks that you have to tackle. The other part is that, contrary to software development, this is an industrial process. You actually need a factory in the background to train models. Just a good idea on a laptop is not enough.
Mm-hmm. Good point that you're just raising, just the idea and the laptop, because I assume that the idea of having your own model, a lot of companies are out there that actually do have this vision and do have the ambition, and they want to have their own models, but it comes with challenges. And also the challenges are not minor, that you overcome with a small step, right? So I also want to go there.
It needs to be strategically important for you to be willing to do it. Like, in the same way, coming back to the analogy, you need to know why you've chosen to build your own engine, because you can totally buy someone else's engines. It's okay. Yes, but there is a point where it's important, and it's not going to be easy. But if it was easy, then it wouldn't be worth solving. Then you could buy 100 engines from hundreds of suppliers. It will be difficult, it will be painful, but if you need to have control over it, you need to have control over it.
Yeah. What were one of the challenges that you had to overcome on the
One?
journey from like I know it was like we only got 1 hour. I couldn't believe it. Yeah, but like, or maybe you pick maybe one or two that you would want to share, especially in this conversation, that were your learnings, because we also on this whole journey, I know that we had some bitter pills to swallow in realizing how we were working before and how we need to work now.
Sure. Before we talk about challenges, I think they are important. It's also important to realize that AI is one of the very few horizontal layers of technology that humanity has ever seen. This is incredibly rare. We have seen the advent of language itself, of course, both spoken and written. Okay, like this makes everything better, right? Like all the problems we need to tackle are enhanced by our ability to exchange information via language. And then for a long time, it's not obvious where the next like horizontal layer of technology comes in until basically like steam engines and electricity, right? Like all of a sudden, once again, there is this one technology that advances many different avenues of human development, followed by computers and the web. And now it's like the fifth wave of this kind of event happening. They are incredibly rare. This is not an isolated advancement in some pocket of the industry that will only benefit a small select group of people. This is going to drive all of humanity forward. So in light of the significance of that event, the number of challenges you have to overcome should be put into comparison. Yes, it's very difficult to build AI models. It's especially difficult to build AI models that compete on a global scale. And there are many problems to solve. The biggest problems are, of course, talent. Like you need incredibly capable and dedicated people in order to advance any line of research. AI model development is no different. AI infrastructure also very difficult, and we are certainly lacking in Europe in terms of our abilities to show the same kind of conviction that our counterparts in the US and China do. And these are all problems we absolutely have to tackle. But at the end of the day, what we are building here is the next horizontal frontier for all of us, and that doesn't mean someone abstract foreign that you don't know. I mean, like you and me included.
In a complex engineered system, all of the things need to work. Yes. Typically, if one of the things fails, the entire system fails. Of course, many safety systems are designed with redundancies, but in principle, all of the things work. And if it's a complex system, there are really a lot of things. I don't know to what extent I should use AI analogies, but think about a nuclear reactor. Like the principle of a nuclear reactor is simple. If you get enough fissile material sufficiently close to each other, that's it. That's your nuclear reactor. But that's not the entirety of the problem. You have to solve, millions and millions of sometimes seemingly trivial engineering tasks. Oh, how exactly do I do the pallets? How do I, prepare the fuel in the first place? How do I align them? What is the moderator? How do I remove the heat? How do I convert it into steam? How do I control for steam temperature? It's exactly the same with artificial intelligence. For you to be successful, you have to solve all of those problems. A lot of those problems we are trying to solve and we're trying to hide on behalf of the community, of the ecosystem, but a lot of those things people need to, one by one figure out by themselves. Operational problems, data creation, data cleaning problems, scalability problems around operation in a data center. Hey, what happens if a job crashes? Do we just allow this expensive system to sit idle for many hours? And is it okay to fix the problem a couple of days later? Well, maybe not. So I think there is no secret sauce. The secret sauce is to build quite large, very capable teams, allow them to fail a couple of times, empower them to fix the problems that they face, and a couple hundred iterations afterwards, you have a great outcome.
Yeah.
It's a disappointing answer, but I don't think there is a secret sauce.
Yeah, but I think that's a valuable insight, or great to share from you being the pioneers currently in the field, and because we have the strategic drivers, we have the technical drivers, and I think especially why we are here sitting together, because you are the forerunners for so many more companies hopefully to follow, right? Especially in Europe, and that's what we want to emphasize on today. And you as DeepL, you were not only one of the first ones first users to use DGXG B200 NVL72, but you also pioneered the FP8 development. So maybe we can talk about that as well, because that's why I hear you here on stage inspiring that you're like with this step-by-step approach of curiosity, of exploring, of facing challenges, that you are at the point where you're running with the speed of the development that we are currently seeing in the market.
Yeah. As a company, we have always been at the forefront of what AI development looks like. And for the first couple of years, the compute requirement was substantial, but manageable by common hardware. Say. You had to be a bit clever on how you extend compute across like a single machine to many of them, but beyond that, it was fairly simple. And with the advent of LLM specifically, all of this changed drastically. In 2022, we made the decision to basically disrupt our own tech stack, right? All the hard work that we had put into our prior model architecture, the way we had run our data centers, to invest into DGX specifically, and LLMs as a technical vehicle to drive the state-of-the-art of language AI forward. That again, like, was not obvious at the time. It would become obvious a couple of months later, like with the advent of ChatGPT. But prior to that, this was really driven by a conviction. Okay, like we have essentially exhausted all of humanity's work done in translation. How do we make more progress? And the way to make more progress is to bring in more knowledge. And if you run out of translated knowledge, you have to take non-translated knowledge. And like we had a number of experiments on how to do this on the prior architecture, but it always felt limiting and it wasn't as scalable. Like our attempts to scale this up just didn't work. And then with LLMs, we saw, okay, like here's a way to do this. It's kind of foreign to us. Like it's not a natural fit. Like I could easily argue why our former architecture was a better fit for the problem we wanted to solve, but at least it's scalable. And one of the lessons that everyone in AI learns over and over again is there is a lot of power in building scalable systems and exposing them to more data. Because then all of a sudden, all the problems you try to solve very explicitly are somehow solved implicitly. So you don't have to worry about this as much and can work around the problem to some extent. The degree to which this kind of approach succeeds is staggering. And I don't think that anyone would have reasonably predicted this in like 2020 or even earlier. But it happens to be true over and over again. And as a result of this, like bringing in more data and more compute is part of the mix. Rethinking how these systems work at scale, also very important. And then if we dive into like specific details, yes, there are many of them, right? Like lower precision training is something that we have invested in early because it was like driven by the need for us to
necessary.
Yes. Good use of the amount of compute we have, also to serve like many millions of customers efficiently. That is important. And we will continue to do more there, right? Like FP8 is not the end of where this is all going. Now with Blackwell, FP6 and FP4 are on the horizon. But as Adam has already said, it's not that you have to get one aspect right. It's that you have to continue to put advancements across the entire stack. And that includes like building your facilities, getting data, model architecture, getting inference right. It's incremental improvements across all of these domains.
For those of you that don't know what FP8 is, when you use any computer system, you can represent numbers with varying amount of bits. Yes. And traditionally, when you fire up your scientific calculator on Windows, that will operate with 32-bit numbers. Yes, and we're of course, as NVIDIA, pushing the limits of technology, and we're building as fast silicon, interconnect, and memory as possible. But what you don't want to do is you don't want to reach kind of the limit imposed by hardware and say, hey, that's enough, we give up. So we're trying to be cheeky about it and try to find other different ways of squeezing more performance from the hardware that we've built. You know, one of the ideas is, okay, we have finite speed of memory, but if we move half of this stuff from that memory, suddenly we have double the speed. So we've decided to invest quite heavily initially in 16-bit numerical representation, cutting the amount of numbers that we have to move in half, then in 8-bit. And now we have 4-bit representations that seem to be suitable for training. It's not as simple as just removing bits. Those are fairly involved numerical representations, and a lot of trickery is necessary to actually force them to work. But this is one of those countless things that you need to get right in order to get the performance that you need. Like, of course, fast silicon is important, but it's just part of the puzzle.
Yeah, there are so many aspects, which is great news to many people out there listening right now, because it means that you can contribute in like very different areas of the stack.
Correct.
Like,
yes.
Room for linguists to chime in and advance the state of AI. There is room for like scientists and computer engineers to do the same. Also at this point, right, infrastructure becomes such an important part of this that we see the advent of a lot of like job functions you wouldn't have put into AI development to really push the boundary. It's a great time to be in data.
Like in physics at the beginning of 20th century, like it was obvious what problems to tackle. It I think is now quite obvious what problems to try to tackle in this space. And there's a ton of low-hanging fruit. Like, have you ever thought, why does PyTorch need to crash when one process goes away? Well, it doesn't. Like, just no one bothered or had the energy and willpower to do something about it. And okay, so and wherever you look, there are problems. So it's a great time to be in this field, I think.
I've been saying this for the entire time I've been in this field, and I will probably say this for many more decades to come. It really feels like we are at the very beginning of what this entire field is going to look like. It feels very much like the 1960s of computing, in the sense that there are so many obvious challenges that we haven't addressed yet, just because of like time.
And people.
And we will see advances across all of them. Like, favorite example of recent is, okay, why do we reward an entire trajectory in reinforcement? It really makes sense, right? Like, what we actually want to figure out, what are the useful parts and what are the non-useful parts out of these long reasoning steps.
Or optimize it. Like, why the hell do we use primitive tools? Like, for Adam, it's already an improvement, but why? Like, could we do better? And now with Kini, you asked about it a couple of days ago. Yeah, of course, there are a lot of things you can do. And everywhere you look, there are things that you could conceivably improve.
I hope you can feel that wherever you're sitting right now, in the office, in your home office, on the couch. I hope you feel the passion that that I feel now here in the room when you guys are really getting into the topic. So thanks for sharing that. I have like 2 more questions, especially because you talked I love your mindset when it comes to solution oriented and like this exploration phase that we are in, and that we will tackle it one by one. And many of these challenges are already, or you faced already challenges in the past that you have overcome, you found solutions for. And I wanted to address one tool here, the Sensor RT LLM, like because we also both spoke about scaling large models, a massive amount of requests that you are handling when it comes to translation requests from the outside. How can a tool like this help address these challenges?
Want to take it first?
Well, if you look at modern cars, yes, like what do you have? You have an on-off switch, yes. In Tesla, you don't even have. Now you again have a directional indicator. But you have a steering wheel, gas, and a brake. Yes, that's everything that you get as a user, and the car just works. But it doesn't just work because that, as an engineered system, is easy. It's because someone invested tremendous amount of work into countless different software and hardware solutions to make it work. So you release the brake, and the car does not roll back. Yes, you apply gas, and the car rolls gently up. Despite the fact that there is a gradient. Someone hid all of that complexity. I think with neural networks, we're not at the point in time where all of that complexity is hidden. Yes, and unfortunately still, to get this car moving and moving slowly, there is a fair amount of engineering required. And TensorRT is a library that allows people to build some of that complexity when it comes to usage of neural networks, in particular autoregressive models. And it's an important library for us because the better we are at TensorRT, the cheaper it is for you to do your business. So we treat it very seriously, and we're very grateful for a lot of feedback. Yes, a lot of feedback that we're trying to tackle one at a time. And yeah, it's one of many tools that we built to make sure that this technology can exist.
Maybe to zoom out a bit, in 2017 again, things like TensorRT LLM didn't exist. So we had to build a lot of software ourselves even to get started.
Sure.
And then once we built the software, we soon realized, okay, there's a lot more software we need to build. And it turns out that a lot of the software that you need to build for AI development is undifferentiated heavy lifting on the side of companies, which means that everyone needs it. It's not bespoke to any individual company, so it makes a lot of sense to pool these resources and make sure that everyone benefits. We have done this in the past by contributing to open source projects that did some of this undifferentiated heavy lifting for us. The amount of scope of software development particularly is certainly equal, if not exceeding, the amount of work that has been done on advancing the actual hardware. Both of them are incredibly important. And the importance of like even minute software improvements
can be dramatic.
Benefits everything. So it means that you scale up AI development, you get outsized returns. And I'm very happy to have now companies out there, also like open source projects out there, who pool these resources and make sure that we not only lower the barrier of entry for everyone, but also make sure that at an increasingly large scale, we use this technology efficiently and make sure it can benefit humanity at the scale it really needs to get to. There's a long way to go. It's not that we are anywhere near the finish line, but again, by many engineers continuously pushing against all these sub problems, we have been making incredible progress.
And it's not just TensorRT. I think this is our core area where we care about a lot. All of those lower layer libraries that underpin all of our tools, but also tools of our partners. So it's not just TRT, LLM, TRT. It's also a transformer engine. Yes, it's also cuDNN. It's Nickel. It's Nixel now for inference. It's Megatron Core. I might have mentioned it already. There's like this entire family of those lower layer libraries that building them takes forever, and that are critical and really underpin utilities such as PyTorch. Yes.
And that's interesting balance. Like we absolutely want everyone to be able to contribute and
sure.
be as easy as possible to get started. Right? AI hackathons are a thing now, and 10 years ago they wouldn't have been, just because it was too difficult to even get started. But now, like within a weekend, you can make
something,
right? Reasonable progress, at least get started. At the same time, we also have to ensure that we continue incentivizing people to dig a lot deeper into the underlying layers and help improve them. Because there's always this risk in technology. We've seen this a lot in computers, that you make the entire experience a lot more seamless and simple, but it also creates this artificial barrier for people to dig in. Like when I was a child, I still had to build my own computer. I had to debug it, and when the platter crashed, I had to fix it, right? Nowadays, okay, your iPhone doesn't work, you take it to a store, and that's about it. So we do tend to remove people from having the same access to the underlying layers. That is something that worries me. And I was particularly happy to now have received DJX Sparks, which are like small versions of the same kind of system, which once again shift the availability of this technology into much more accessible areas, right? Like ever since I have now tinkered with underlying libraries like Nickel and CUDA that I would just not have touched before. First of all, because at work I just don't have the time. I'm busy making sure that everyone else can use these technologies, so I don't get to use it as much anymore. And also because it feels really wasteful to spin up this incredibly expensive AI supercomputer just for me to tinker with like things that I'm generally curious about. By bringing this technology closer to people who are interested in tinkering, that's one way we can make sure that we have the supply of talent in order to push this technology.
And that knowledge doesn't just appear. It's not something that some of it you'll get from university or such, but unfortunately, until you, in most things in life, and until you do things, you don't know how those things work. It's just unavoidable. So it's important that we create those opportunities.
I think it's great that you both, throughout this whole conversation, really focus also the human talents, the knowledge, the curiosity. These are very human characteristics, right, that we actually need in progressing, in making, creating technology and finding new solutions. And maybe that's a great bridge from that point on to move on to my closing question. I started with a personal question. I also wanted to close with one and bring in the human aspect, because that's one of my missions, to bring technology closer to humans, because we did talk about scale and speed and innovation and technology, and that's what all gets us thrilled when we see how fast it's moving, right? But if we look ahead, my question to you is, how does human progress through AI mean for you personally?
Go.
So, as I've already touched on, AI is not one thing, right? It means like technological advances in many areas of our lives. And there are many more advances that we will see that right now no one has even conceived of. They are just entirely untouched greenfield projects. We've seen this in recent years in a couple of fields here and there popping up. AlphaFold advances, both medical and biological research powered by AI. We see all these surrogate models that help us to speed up physical simulation in like climate change, science and beyond. There are many more areas to be discovered where this technology can be impactful. What's really inspiring to me is how many people get to benefit from this technology today, right? Like everyone can go to DeepL or to ChatGPT and benefit from what is cutting edge technology at a moment's notice. What I personally see is information has been accessible to us in principle for, well, 2 decades now, right? With AI, this has seen yet another boost in how quickly you can get to the point. I've done a lot of work in like IT infrastructure in the last year, and the time to get me to completion has easily lowered by a factor of 10. So we can get a lot more work done in the same amount of time. And a lot of that work is work that needs to get done, but it's not the main reason we are in this chosen field. This we will see across many, many more domains. And as a result, yes, like we are somehow challenged to keep up, right, and figure out how to actually harness this technology. But it's also incredibly empowering to see how much wider the scope of our personal impact on this world can be if we leverage technology to our advantage. This is no different.
Thank you. Yeah, like that also tech for good. Yeah.
So the question is, can you paraphrase the question again?
Yeah, so when it comes to where can we use and leverage AI in this process for humans, for us as society?
So again, you've alluded to that earlier. It's a vertical technology. That's how we put it. So I think in almost every aspect of our life, we'll see some applications. Like we use it to build better masks for silicon manufacturing process. Like the one that I'm particularly interested and fascinated about is, and now we see this explosion of reasoning models. Yes, and I think a lot of people in the audience have some understanding of the capabilities of modern neural networks, not just to give an answer, but to think through the process that leads to the answer, and not just give you the raw facts, but also the entire chain of thought, the entire thinking process associated with generating that answer. But I think what we are starting to see is systems that bring it to another level, systems that don't just spend like seconds, minutes, quarters of an hour on a problem, but hours, days, potentially weeks, and not to just execute those thinking traces on a single machine, on a single GPU, but on very large computational systems. And I'm genuinely curious to see what those types of solutions will do to research, will do to academia, I think at some point they will also integrate, be integrated with HPC tools. So I don't see a reason why a reasoning system like that couldn't schedule execution of experiments using, I don't know, some Schrödinger simulation software or some chemical biological software, then move into kind of the wet lab. I think we'll see in parallel to progress in artificial intelligence, potentially quite significant progress in science. Even simple applications like ability to do better, more systematic literature review in a world where just on arXiv there are 700 papers every single day. I think that will change a lot of lives, and as a second order derivative, change our lives like that. So we're having a lot of conversations about the role of our HPC systems in Europe, not just as places where scientists get some compute to carry out an experiment, but as a place where, I don't know, a psychologist can have a conversation with a thinking machine like that about the area of their research. I think that is something that is very important, and I think we'll see reapplications of those technologies also in other places. So if you can have it on a scientific system, answering questions about chemistry, could you do the same thing within the CEO office, having a conversation about business strategy and competitive analysis of your products? I think you could, and I think at some point in the near future, every CEO office will have at least a budget for thinking machines, not for inference, but for thinking. Yes. Similarly, should every project that consulting companies provide have some thinking time allocated to it? I think it should. And should policymakers have some thinking time on the side? And even if the results of that thinking is not what they want to accept, it's still good to think through those problems in a way that a single human being cannot achieve. Like a single human being cannot within a week read 20,000 books. That's just not possible.
Yeah, that's a challenge accepted.
Since you touched on literature review, fun fact, I was talking about the DGX market right? Literally last Saturday, I began a new repository, which has just one goal in mind. I want to chat with AI literature.
Yeah.
And of course, like, you should do data scraping and so on. But yeah, like that's what I mean when I say information is not just more easily accessible in its raw form. It's also more suitable to solve the specific problem you're trying to get.
Now I got them talking. So thank you. So we unfortunately, because I promised the audience that we still take some questions. So my takeaway also from the questions and also your very last question is really that whatever is going to happen next, it's beyond imagination, because we haven't solved it yet. And we need to keep being curious. We need to dig deeper. We wanting to not only solve the issue that is right in front of us, but being open to every single step that is still coming afterwards. And I think that's for me right now here very inspiring, and I hope that came through the camera as well. And yeah, like I said at the beginning, learning a lot also means that we are stepping out of the unknown field. So we now know what we still need to learn about. And that's why I'm very happy that I got a secret letter here with some of your questions from the off. And we picked 2, and we will have the time. And like I said, remember, if it's not yours, please stay in the chat, stay in the socials with us. We'll get to them as well. So the first one for you, Stefan, is that everyone acting in the market will need to have agents. They need AI governance. Do you think that can be outsourced?
Outsourced by companies to centrally deployed institutions?
You just added to the question, if that's a good point to start to talk about. Yes.
So sort of high level governance. It's powerful technology. We need to not only make sure that it works, but also be mindful about how we deploy this. This cuts both ways, right? Like by our increased capability to take good care of AI-specific governance, we open up the envelope of problems we can address with this technology. So it's like, it's not just, like, at the end of the day, we need to balance capabilities with control. And creating agreed upon standards on how governance is supposed to happen will make it a lot easier for companies to leverage these technologies, because they don't have to reinvent from scratch how exactly this kind of deployment is supposed to happen in their domain. Can it be outsourced? I think it should be definitely an open discussion shared with like many parties involved and like different points of view on the entire issue. At the end of the day, to an extent, this also needs to be on you as like a company to decide how exactly what to conduct business.
Don't you think that sometimes people overthink those problems? Like, I think many companies, like your agent system, yes, thank you for giving me access on Monday. I wrote a piece of code, yes, and that code does certain things. If I wrote that without your tool, without your agentic tool, I would have written that code that way or another. It might have taken more time, it might have been of lower quality, but there would have to be some governance in place to accept that code and integrate it into our processes. I'm not exactly sure that problem changed hugely, did it really? The scale of it, maybe.
So especially when talking to customers, what I see is, first of all, a lot of curiosity, which is great, but also a lot of uncertainty, right? Like, oh, we know we need to do something about AI, but we don't exactly know how it's supposed to look. We are not the experts. Can you help us guide through this transition of change? And in that sense, I do not think that people are overthinking it, because essentially they're asking for help, right? They're asking
absolutely.
experts, can you help us?
That's a talent topic again. Yeah.
On another level, I think that we tend, like as humans, to get involved in discussions that are not very fruitful, worrying about risks that have never materialized before. And also there is this very persistent phenomenon that we expect artificial systems to be entirely perfect, but we allow for a lot of flaws in human operators. And that is a discussion I think is not super fruitful, because we should absolutely talk about reliability and
relative improvement.
But we also must recognize that a system that inherently learns, like imitates human behavior, also needs to come with a manageable but non-zero amount of flaws in its execution.
And as a consequence, supervision when it's necessary, yes.
Absolutely.
Second question for you, Adam, and then the last that we take here is obviously Europe is very diverse, and we have different clients approaches, way more clients than in the US, for example, or other regions. How is NVIDIA tackling the regional differences in adoption?
Well, Europe is diverse, of course, and we have a lot of languages. And the performance of some of those models it differs between those languages, and I don't think we've solved for that problem. Yes, so I think in Europe we still don't necessarily, we are not as good at measuring how good those neural networks are, yes, as English-speaking users. So that's something that we need to tackle. We need to be great at being able to answer the question: what does it mean for a neural network to be great at German? I don't think we know how to do that quite yet. So we have projects focused on that. But bear in mind, this is not we didn't just appear in Europe yesterday. We have a lot of employees, even in my team, scattered across Europe that understand the local companies, their businesses, their constraints. And from our perspective, it's a business as usual in a sense. Would it be more convenient if our customers were more consolidated, larger? If we had, maybe it would, but would it be more interesting? I'm not sure.
Fun.
It would always be great if the environment we are operating in would just be simpler. And apply it to both elements, etc. It is the infrastructure we are dealing with, and one of the reasons we should take sovereignty very seriously is that this equips us with control to care about these kinds of mechanisms, right? The US provider might not care that your LLM works great at Polish, for example. They may not, but in Europe specifically, incentives are well aligned to make sure that everyone benefits from this thing.
And I don't think people do it deliberately. Like they don't just sit at a table and say, we'll deliberately ignore that language. It's just, we've discussed it earlier, there's a very finite amount of people.
Look, even for us, like DeepL, right? Like a company designated to breaking down language barriers, our German models are typically the ones that get the most attention, not because this is where we think we should ideally be headed, but because it's convenient, right? Mm-hmm. Similarly, very convenient for US companies to worry about English first, and then, yeah, maybe some time, like in the backlog, we can take a look at.
Which we're working hard to address that as well.
And I think it's a good aspect that, especially in Europe, we embrace it. We embrace the diversity, the different languages, and we talked about this. The sovereign AI is part and will be driver of not eliminating it, but keep embracing all these different aspects. And that's what I like about the approach here, the discussion. And we're unfortunately already at the end of the session. And thank you both of you for being here today with us, with me in the room, and for your insights and answer your questions, my questions, and from the audience. I'm pretty sure that there are even more in the chat. That's why I already gave you the heads up. Thank you for all of you at home in all the different offices out there for tuning in, for sending us your questions. And if you want to know more first, but also if you want to rewatch certain questions, if you want to share with colleagues, maybe you dialed in and now you're very inspired and you want to share with your cohort, you can do that with the link that you used on YouTube. You can share this, so the recording of this live stream will still be available for you afterwards. And bear with me, we still have one more important information because we don't stop there. So that was basically the beginning. That was the warm-up intro, the teaser that we did here. Because next Thursday, on November 20th, at 10 a.m. Central European Time, we'll be hosting a more even technical demo where NVIDIA and DeepL technical experts share how to leverage innovative training approaches we talked about today, like FP8 precision training, LoRa adapters, and mixture of experts. And we basically everything that we touched base on today, they will talk about the sensor RTLLM solutions, and obviously they will talk about you will then gain insights about future roadmap topics for model training and inference to understand on the one side the business value, obviously, that we also focused here today, but really the technical innovation underlying for the next generation of translation AI. So I'm very happy that I'm able to moderate today, but that I can invite you to this next deep dive session. And please register via the link in the chat that will be shared on your screen right now on the slide. So you should all be able to register right away and mark it in your calendar. And that only leaves me to say goodbye, to say thank you again for you. Thank you at home, and have a great afternoon, and take some of the spark that we got here from the room to your family, to your colleagues, to your companies. Looking forward to see your feedback.